Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most unsettling questions ever asked about our universe. A question so simple, it almost feels harmless at first. But as we sit with it, gently turning it over in the mind, it begins to change shape. It becomes heavier, stranger, a little harder to set aside. Before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a quiet comfort to see all the places we gather from, each in our own little pocket of night. Now feel free to dim the lights, maybe let a fan hum softly in the background, and let's gently begin our journey together. And if your mind starts to wander, that's perfectly fine, let it drift. We'll still be here, slowly unfolding the story. It begins, as many things do, with a simple question, not shouted, not dramatic, just spoken, almost casually over lunch. Where is everybody? You might imagine the scene. A group of scientists sitting together, the kind of quiet conversation that drifts between ideas the way clouds drift across a late afternoon sky. Someone mentions flying saucers, those strange headlines that seem to come and go, never quite settling into certainty. And then, in the middle of it all, one man pauses, thinking for a moment longer than the others, and he asks, "Where is everybody?" At first it sounds almost playful, like something a child might ask while staring up at the stars. But the question lingers. It doesn't leave easily, because behind it sits something far larger than it appears. You see, when you look up at the night sky, it feels vast, quiet, almost empty. A scattering of stars, a gentle glow stretching across the darkness. But that feeling, that sense of emptiness, may not be telling the whole story. Because when scientists began to really understand the scale of the universe, something unexpected happened. The quiet night sky started to feel a little too quiet. There are hundreds of billions of galaxies in the observable universe, each one filled with hundreds of billions of stars. And around many of those stars we now know there are planets. So many planets that it becomes difficult to picture. Worlds of rock and ice and gas circling their stars in silent orbits, some warm, some cold, some perhaps not so different from our own. If you were to imagine all of them together, it wouldn't feel empty at all. It would feel crowded, almost impossibly so. And yet, when we listen, there is nothing. No voices crossing the distance. No signals that clearly say we are here, no distant echoes of civilizations reaching out into the dark. Just a quiet, steady silence. It's a little like walking into a city you are certain would be alive with sound, lights glowing in windows, voices in the streets, footsteps echoing in the distance, and instead finding everything still, as if everyone had been there and then quietly left. Or perhaps never arrived at all. And that is where the question begins to change. It's no longer just curiosity. It becomes a kind of tension, a gentle unease that settles in the background of your thoughts. Because if the universe is as vast as it is, and if the conditions for life are not unique to Earth, then something doesn't quite add up. There is a gap between what we expect and what we observe. And that gap has a name. It's called the Fermi Paradox. But you don't need to remember the name. The feeling is enough. It's the feeling of standing in a place that should be full of voices and hearing only the soft hum of silence. Now, there are many ways to explain that silence. Some are comforting. They suggest that life is rare, or that we simply haven't looked carefully enough yet. That somewhere out there, across unimaginable distances, others are living their own quiet stories just as we are. And perhaps one day we will find them. But there are other possibilities too, quieter ones, more difficult to sit with. Possibilities that suggest the silence is not an accident, but a pattern, that it may be telling us something, not just about the universe, but about what tends to happen to civilizations like ours. Not all at once, not in a dramatic moment, but slowly, repeatedly, quietly, like candles that flicker for a while, and then go out. It's a strange thought, isn't it? That the silence above us might not mean there was never anyone there, but that something happened, something that tends to happen, and that we are only now beginning to notice the shape of it. But we're getting ahead of ourselves. For now, it's enough to sit with the question, to let it rest gently in your mind without trying to solve it too quickly. Where is everybody? It's a question that doesn't demand an answer right away. It simply waits, like the night sky itself, still, patient, quiet. And as we continue, we'll begin to explore what the universe, in its silence, might be trying to tell us, one small piece at a time, as softly as the turning of the earth beneath us. If you sit with that question for a little while longer, something subtle begins to shift. At first, it feels like a mystery, a quiet curiosity, the kind that drifts gently through your thoughts without demanding too much attention. But then, almost without noticing when it happens, the question begins to press a little more firmly. Because it turns out this isn't just a poetic wondering about the stars, it's something we can actually try to estimate. Not perfectly, not precisely, but enough to get a sense of what should be out there. And when scientists began to do that, the silence became harder to ignore. In the early 1960s, an astronomer named Frank Drake tried to do something quite simple in spirit, even if the details were a bit more involved. He wanted to estimate how many civilizations in our galaxy might be able to communicate across space. Not by guessing wildly, but by breaking the question into smaller, more manageable pieces. Instead of asking, how many civilizations are there? He asked a series of gentler questions. How often do stars form in our galaxy? Of those stars, how many have planets? Of those planets, how many might have conditions suitable for life? And from there, step by step, the question continues. How often does life actually begin? How often does it become complex? How often does it develop intelligence? And finally, how often does that intelligence build technology capable of sending signals into space? Each step is uncertain. Each one carries a bit of mystery. But when you multiply all those chances together, even using cautious, careful estimates, you don't get zero. You get something surprising. You get a number. And that number is not small. Even if you imagine that many of those steps are difficult, even if you assume that life is rare and intelligence even rarer, the sheer number of stars in our galaxy, hundreds of billions, means that the final result should still leave us with, at the very least, many thousands of civilizations, possibly far more. And that's just our galaxy. Beyond it, there are trillions of others, stretching outward in every direction, each one filled with its own countless stars. It's a little like standing on a beach and trying to count grains of sand. At some point the numbers become so large that they stop feeling like numbers at all, and begin to feel more like inevitability. Given enough stars, enough planets, enough time, life should arise, again and again, and sometimes that life should look up at its own sky, just as we do, and begin to wonder, and sometimes it should build something, a signal, a message, a quiet attempt to say, we are here. If even a small fraction of those civilizations reach that point, then the universe should not feel silent, it should feel busy. Not necessarily crowded in a way we can easily see, but active, alive with faint whispers crossing the dark, signals overlapping and passing one another like distant conversations carried by the wind. And yet, when we listen, there's nothing we can clearly recognize. For decades now, we have been listening. Large radio telescopes have been turned toward the sky, patiently scanning, slowly sweeping across the stars, searching for patterns that don't belong to nature. The kind of patterns that might suggest intention, repetition, structure, something that looks less like random noise and more like a message. There has been one moment, just one, that made people pause. In the late 1970s, a signal was detected at a very specific frequency, one that scientists had long thought might be a natural choice for communication across space. It was strong, clear, unusual. It lasted for just over a minute, and then it was gone. It never returned. Despite decades of careful searching, despite pointing more advanced instruments back toward the same region of sky, hoping to catch even a faint echo of it, nothing like it has appeared again. It's a little like hearing your phone ring in the middle of the night, answering it, and finding silence on the other end. No voice, no explanation. And when you check again later, there is no record that it ever happened. That single, fleeting signal has become something of a quiet symbol. Not proof of anything, but a reminder of how close we sometimes feel to hearing something more, and how quickly that feeling fades. Now, it would be easy to assume that perhaps we simply haven't been listening long enough. After all, a few decades is not much time compared to the age of the universe, and there is truth in that. We have only just begun. But here's where the question deepens again, because listening is not the only way we search. Even if no one is actively sending messages, advanced civilizations, if they exist, might still leave behind signs of their presence. Not deliberate signals, but traces. Subtle changes in their environment, large-scale structures, energy use on a scale that alters the light of their stars. Imagine for a moment a civilization that has learned to capture a significant portion of the energy from its star. Not in a dramatic science fiction sense, but gradually over time building structures that absorb light and convert it into useful energy. From a distance, that star would look different. Slightly dimmer in visible light, slightly warmer in another range, as unused energy is released as heat, not something you would notice with your eyes alone, but something that careful instruments could detect. And we have been looking, studying stars, measuring their light, searching for anything that behaves in a way we can't easily explain. So far, nothing stands out in the way we would expect. The same is true for planets. We can now examine the atmospheres of distant worlds, looking for chemical signatures, tiny imbalances that might suggest life or even industry. On Earth, for example, our atmosphere carries subtle signs of what we do, traces that, from far enough away, might hint that something unusual is happening here. And yet, as we look outward, we don't see clear evidence of anything similar elsewhere. No unmistakable fingerprints of a technological civilization. Not yet. And so the picture becomes a little more difficult to ignore, because it's not just that we aren't hearing voices, it's that we aren't seeing footprints either. No messages, no echoes, no lingering signs that something was once there and has since faded. Just quiet. A quiet that stretches not just across space, but across time. And when you begin to see it that way, the question shifts once more. Not just, where is everybody? But something a little more unsettling. If the universe should be full of life, and if life sometimes becomes intelligent, and if intelligence sometimes builds technology, then why does everything still look so untouched? It's a question that doesn't rush you, it doesn't demand an answer, it simply stays there, gently waiting, as we take one more step deeper into the silence. As that quiet question lingers, and as we begin to understand just how many places life could exist, something else slowly comes into view. It's not just that we've been listening, it's how carefully we've been listening. For a long time now, humanity's been doing something rather unusual. We've been pointing our instruments outward, not to look for stars or galaxies or planets, but to listen for something far more delicate. A pattern, a signal, something that feels intentional. Imagine sitting in a quiet room late at night, with a radio gently humming beside you. You slowly turn the dial, moving across frequencies, listening for anything that doesn't quite belong to the usual static. Most of what you hear is noise, soft, random, unstructured. But every now and then you might catch something, a voice, a piece of music, a pattern that stands out against the background. That is, in a way, what we've been doing with the universe. Only instead of a small radio, we've built enormous listening instruments, radio telescopes stretching across deserts and valleys, quietly collecting faint whispers from the sky. They don't make a sound as they work, they simply gather information patiently, hour after hour, year after year. And what they are listening for is not just any signal, but one with structure, something that repeats, something that carries a rhythm, something that looks less like nature and more like intention. Because natural processes, for the most part, are messy. They produce signals that rise and fall irregularly, that scatter across frequencies, that don't carry the kind of clean, repeating patterns we associate with communication. So the search becomes a kind of filtering, sifting through vast amounts of cosmic noise, looking for even the faintest hint of something deliberate. And over time, that search has grown. Early efforts listened to just a few nearby stars, like someone gently tapping on a handful of doors, hoping for an answer. But today, the scale is much larger. We are listening to millions of stars, scanning wide ranges of frequencies, from lower tones to higher ones, covering the kinds of signals that physics suggests might travel efficiently across the vast distances between stars. It's a little like casting a net, not in water, but across the sky, wide enough that, if something obvious were there, we might expect to notice it. And yet, the result has remained the same, a steady, unbroken quiet. Now, there is an important detail here, one that makes the silence more subtle than it first appears. Because when we say silence, we don't mean that the universe is empty of signals. In fact, it is full of them. Stars emit radiation, galaxies glow, pulsars, rapidly spinning remnants of stars, send out pulses so regular they almost feel artificial at first glance. The universe is, in its own way, quite noisy. But it is a natural noise. It doesn't carry the kind of structured, repeating patterns we would expect from a civilization trying to communicate. And so the search becomes more refined. We're not just listening, we're trying to recognize something that might not be obvious. And this is where a deeper complication begins to emerge. Because there is a curious idea from the study of information, something that feels almost like a quiet paradox in itself. The more efficiently a message is compressed, the more it begins to resemble randomness. In other words, the most advanced way to send information might produce a signal that looks, to an outside observer, exactly like static, like noise, like something you would ignore. It's a little like receiving a book written in a language so unfamiliar and encoded so efficiently that to you it looks like a page full of scattered symbols with no meaning at all. The message is there, but you have no way to recognize it. And so, It's possible, at least in theory, that we are surrounded by signals constantly passing through us, slipping quietly through our instruments, unnoticed, simply because we don't yet know how to see them for what they are. It's a strange thought, almost comforting in a way. The idea that the universe isn't silent, just misunderstood. But even here, the quiet remains difficult to explain fully, because listening is only one part of the search. We are also looking, carefully studying the light from distant stars, examining how it changes, how it behaves, whether anything about it feels slightly off. Because even if a civilization chooses not to send messages, it still uses energy, and energy leaves traces. Imagine for a moment a city at night. Even if no one speaks, even if every window is closed and every door is locked, you would still see the glow of lights. You would still feel the presence of activity. A city cannot hide its energy use completely, and on a cosmic scale, the same idea applies. If a civilization grows large enough, if it begins to use significant amounts of energy from its star, it should leave behind subtle signs, a slight change in how the star shines, a faint excess of warmth drifting outward into space, not obvious, not dramatic, but detectable. And so, we have looked for those signs, we have examined thousands of stars, measuring their light with extraordinary precision, searching for anything that doesn't quite match our understanding of natural processes. We have studied the atmospheres of distant planets, looking for unusual combinations of gases, chemical fingerprints that might suggest life or even industry. And so far, nothing stands out clearly. No unmistakable signs of large-scale activity. No clear evidence of something artificial. Just the quiet consistency of natural processes unfolding across the cosmos. And this is where the silence begins to take on a different character. Because it is no longer just the absence of messages, it is the absence of residue, no footprints left behind, no lingering warmth from distant cities, no altered skies hinting that something once lived there and changed its world. It's as if the universe has remained untouched. Or perhaps that whatever does arise does not last long enough to leave a mark. That idea doesn't arrive all at once. It settles slowly like a thought you weren't quite expecting, because it suggests that the silence we hear and the emptiness we see may not be separate things. They may be connected, two sides of the same quiet pattern. And as that possibility begins to take shape, the question shifts once again. Not just, why don't we hear them, but something deeper. Why don't we see any sign that they were ever there at all? It's a quieter question, but in some ways, a heavier one. And as we continue, we'll begin to explore the more comfortable answers first, the ones that let the silence remain gentle, at least for a little while longer. At this point, with the silence stretching out in every direction, it's only natural to reach for the most comforting possibility. Maybe we're simply not looking the right way. It's a gentle thought, one that softens the edges of the mystery just enough to make it easier to sit with. After all, we're still very new to this. Our ability to listen to the universe, to truly listen, with instruments designed to detect faint signals from across unimaginable distances, has only existed for a few decades. In the grand timeline of the cosmos, that is barely a moment. If the universe were a long, slow conversation, we've only just learned how to pick up the receiver, and even now we may not be holding it quite correctly, because when we search for signals, we are making assumptions. We're imagining what another civilization might do if it wanted to be heard. We imagine them sending out clear, structured transmissions, signals that repeat, signals that carry simple patterns, mathematical sequences perhaps, or steady pulses that stand out against the randomness of nature. In a way, we are imagining them to be a little like us, curious, outward-looking, willing to announce their presence to the unknown. But there is no guarantee that this is how intelligence behaves, even here on Earth. Communication takes many forms. Some creatures rely on sound, others on light. Some use chemical signals, tiny invisible trails that carry meaning from one individual to another. And some, despite being remarkably intelligent, don't seem interested in reaching beyond their own kind at all. So it's entirely possible that when we point our instruments outward, searching for signals that feel familiar to us, we are overlooking something that doesn't fit our expectations. It's like trying to find a conversation in a language you don't yet understand. The words are there, but to you, they sound like noise. And this is where a deeper idea comes into play, one that feels almost like a quiet trick hidden within the nature of information itself. As messages become more efficient, more carefully designed to carry the maximum amount of meaning with the least amount of energy, they begin to lose the patterns that make them easy to recognize. They become compressed, tight, minimal, precise. And in that process, something strange happens. To an observer who doesn't know how to decode them, they begin to look random, like static, like the soft hiss between radio stations. So a very advanced civilization, one far beyond our current understanding, might not send signals that stand out clearly at all. Instead, it might communicate in ways that are so efficient, so optimized, that we would pass right over them without noticing. Not because they're too faint, but because they don't look like messages. They look like everything else. It's a bit like standing in a crowded room, listening for your name, but everyone is speaking in a code so refined that your ears can't distinguish it from the background murmur. The voices are there, but they never separate themselves from the noise. And there's another layer to this, a humbling one, because it reminds us that our understanding of communication, of how information moves through the universe, is still incomplete. Not long ago, we didn't even know how to detect certain kinds of cosmic events. There are ways that the universe carries information that we're only just beginning to explore. Subtle ripples that pass through space itself. Particles that barely interact with anything, slipping through entire planets as if they weren't there. It's entirely possible that advanced civilizations might use methods of communication that we haven't even imagined yet. Methods that leave no obvious trace in the channels we currently observe. And if that's the case, then the silence we perceive may not be silence at all. It may simply be a mismatch, a difference between how signals are sent and how we are listening. But even as comforting as this idea is, it doesn't quite resolve the entire puzzle. Because even if we are missing the messages, there are still other things we should expect to notice. Energy use, for example, is difficult to hide. Any civilization, no matter how advanced, must draw energy from somewhere. And when energy is used, some of it inevitably escapes, often as heat drifting outward into space. It's a quiet, unavoidable consequence of the way the universe works, like the warmth you can feel from a building, even if you never see inside. So even if a civilization communicates in ways we cannot detect, we might still expect to see the faint glow of its activity, a slight imbalance, a subtle warmth where there should be none. And yet, when we look carefully and patiently across thousands of stars, we don't see clear signs of that either. The stars behave as they should. The light matches our expectations. The gentle patterns of nature continue, undisturbed. It's as if, even beyond communication, there is no large-scale presence making itself known. And that's where this explanation begins to feel incomplete, because it suggests that we are missing something. But it doesn't explain why we are missing everything. If even a few civilizations were active in ways that left detectable traces, if even a small number of them used energy on a scale large enough to stand out, we might expect to see at least a handful of anomalies, a few stars that don't quite behave, a few planets that carry unmistakable signs of change. But so far, nothing rises clearly above the quiet, and so the comforting idea begins to soften at the edges. Yes, it's possible that we're not listening correctly. Yes, it's possible that we are overlooking signals we don't yet understand. But it seems unlikely that this alone could account for such a complete and consistent silence. And so, gently, almost reluctantly, we begin to move on to other explanations, ones that suggest the silence is not just a matter of perception, but something deeper, something built into the nature of how life and intelligence unfold across the universe. There is another explanation that feels just as gentle and perhaps even more intuitive. Maybe they were never here at the same time as us. It's a simple idea, one that doesn't require anything to go wrong or anything to be missing. It simply asks us to think about time a little differently. Because when we imagine civilizations in the universe, it's easy to picture them all existing together, like lights scattered across a landscape glowing at once. But the universe doesn't quite work that way. It unfolds slowly, over billions of years. Stars are born, they shine for a time, and eventually they fade. Planets form from clouds of dust, cooling gradually as they settle into stable orbits. On some of those planets, perhaps, life begins. And if everything goes just right, if countless small steps align, life may grow more complex, eventually giving rise to something that can look up and wonder. But each of those steps takes time, not years, not centuries, but millions, even billions of years. On Earth, for example, life appeared relatively early, within a few 100 million years after the planet cooled enough to allow it. But for a very long time, that life remained simple. Single-celled organisms quietly drifting through oceans, changing slowly over immense stretches of time. It took nearly 4 billion years for intelligence, as we understand it, to emerge. 4 billion years. If you imagine compressing Earth's entire history into a single day, intelligence would appear only in the final moments before midnight. And our ability to send signals into space, radio waves for instance, would occupy only a tiny fraction of a second. So when we ask, where is everybody? We may be assuming something that isn't necessarily true. We may be assuming that other civilizations, if they exist, are active at the same time as we are. But what if that overlap is rare? What if civilizations tend to appear, shine for a while, and then fade, each one separated by vast stretches of time? It's a little like walking into a forest and seeing no one there, even though many people have passed through before you, and many will come after. You simply arrived at a quiet moment. In that sense, the silence isn't strange at all, it's just timing. But as we sit with this idea, something begins to feel incomplete. Because even if civilizations don't overlap perfectly in time, we might still expect to see evidence that they were once there. Time, after all, does not erase everything. On Earth, we can still see traces of events that happened millions of years ago. Layers of rock, fossils, subtle changes in the landscape that tell a story, even long after the original actors have disappeared. And on a cosmic scale, some of those traces should last even longer. If a civilization becomes advanced enough, it might begin to reshape its environment in noticeable ways. Not necessarily in dramatic, artificial-looking structures, but in subtle shifts. For example, it might draw large amounts of energy from its star, gradually building systems to capture that energy and use it efficiently. Over time, that would change how the star appears, not drastically, not in a way that would immediately stand out, but enough to leave a signature, a pattern that careful observation could detect. Or perhaps it alters the atmosphere of its planet. On Earth, the presence of oxygen in large quantities is already a kind of fingerprint of life. It doesn't naturally accumulate in such abundance without biological processes constantly replenishing it. In a similar way, a technologically active civilization might leave behind unusual combinations of gases, subtle imbalances that hint at something more than natural chemistry. And these kinds of changes don't vanish instantly. They linger, sometimes for thousands, even millions of years. So even if a civilization existed long ago, and even if it is no longer there, we might still expect to find faint traces of its presence, a whisper left behind in the light of its star, a quiet signature in the atmosphere of its world. And yet, as we look, we don't see clear examples of this. No stars that behave in ways that strongly suggest large-scale energy use. No planets with atmospheric patterns that unmistakably point to advanced activity. Just the steady, familiar signatures of natural processes. It's as if the universe is not only quiet now, but has been quiet for a very long time. And that's where the idea of timing begins to lose some of its comfort. Because it would require something quite specific. Not just that civilizations appear at different times, but that they rarely, if ever, last long enough to leave a lasting mark, that they rise and then fade before their presence can echo into the future. It's a subtle shift in perspective. At first, the idea was simply that we missed them. Now it begins to feel like something else, like they may not have remained long enough to be noticed. And this leads us gently toward a deeper question. Not just about when civilizations exist, but about how long they tend to last. Because if the universe is full of opportunities for life, and if some of that life becomes intelligent, and if some of that intelligence builds technology, then the absence of long-lasting traces suggests something more than coincidence. It suggests a pattern, a quiet, repeating pattern that we are only just beginning to recognize. But before we follow that thread too far, there is one more comforting idea to explore. One that suggests that perhaps the universe is not full of life at all. That perhaps we are rare, not because something stops civilizations from growing, but because very few ever begin. And for a moment that thought feels almost reassuring. There is a final explanation in this gentler group of ideas, one that feels, at first, almost reassuring. Maybe the universe is quiet, simply because life itself is rare, not just intelligent life, not just civilizations, but life in any meaningful sense at all. It's a thought that shifts the question in a subtle way. Instead of asking, "Where is everybody?" we begin to ask, "What if there was almost no one to begin with?" And for a moment that idea can feel comforting. Because if life is rare, if the path from a lifeless planet to something that can think and wonder is extraordinarily unlikely, then the silence makes sense. There's no mystery to solve, no hidden danger waiting to be uncovered. Just a quiet universe, where we happen to be one of the very few exceptions. But as we sit with this idea, we begin to realize that it is not as simple as it first appears. Because while life may feel fragile, the ingredients that lead to it do not seem especially rare. Across the universe, the basic building blocks of life are everywhere. Atoms of carbon, hydrogen, oxygen. These simple elements form naturally inside stars and are scattered across space. When those stars reach the end of their lives, clouds of gas and dust rich with these elements gather together over time, forming new stars and new planets. And around many of those stars, we now know there are worlds that exist at just the right distance, neither too hot nor too cold, where liquid water could exist on the surface. Water, energy, the basic chemistry of life. These ingredients appear again and again. It's a bit like finding that the kitchen is always stocked. The question then becomes, why are there so few meals being prepared? To answer that, scientists have looked more closely at the specific conditions that made life possible on Earth. Not just the presence of water or the right temperature, but a long list of subtle factors that may have played a role. For example, Earth orbits within a relatively calm region of the galaxy, not too close to the crowded, chaotic centre, and not too far out into the sparse edges. It has a large moon, which helps stabilise the tilt of the planet, keeping the climate relatively steady over long periods of time. It has a magnetic field which protects the surface from harmful radiation. It has a system of shifting plates beneath its surface, slowly moving, recycling material, helping regulate the atmosphere over millions of years. And nearby there is a giant planet, Jupiter, which may act as a kind of shield, deflecting or absorbing some of the debris that might otherwise strike Earth. Each of these factors on its own might not seem extraordinary, but together they form a delicate balance, a long chain of conditions that, if altered even slightly, might have led to a very different outcome. A world where life struggled to begin, or never began at all. This idea is often called the rare Earth hypothesis, not because Earth is unique in every way, but because the combination of conditions that allowed complex life to emerge might be much less common than we once imagined. It's like a lock with many tumblers. Each one must fall into place at just the right moment. And while the individual pieces are common, the exact alignment may be rare. But even here, as we explore this possibility, something begins to feel uncertain. Because when we look at Earth's history, we find something unexpected. Life appeared relatively quickly. As soon as the planet cooled enough to support it, simple forms of life emerged. Tiny organisms, simple and resilient, capable of surviving in a wide range of conditions. It didn't take billions of years for life to begin. It began early, and that suggests something important. That the step from chemistry to life, from non-living matter to something that can grow and reproduce, might not be as unlikely as we once thought. If it were extremely rare, we might expect it to take much longer to happen, even on a planet like Earth. But it didn't, and that leaves us with a subtle tension. Because if life begins easily, then the silence of the universe becomes harder to explain. It would mean that there are likely many worlds out there where life has taken root. Not necessarily intelligent life, not civilizations, but life. Quiet, simple, persistent. A universe filled not with minds, but with beginnings. And this leads us to a more refined version of the idea. Perhaps life itself is not rare, but the path from simple life to complex, intelligent life is. On Earth, for a very long time, life remained simple. Single-celled organisms dominated for billions of years. They adapted, they evolved, they spread, but they did not become complex in the way we might expect. And then, at some point, something unusual happened. Cells began to cooperate in a new way. Instead of existing as independent units, they formed partnerships. Structures within structures, a new level of organisation that allowed for greater complexity. And from that complexity eventually came multicellular life, and much later, intelligence. Each of these steps may represent a kind of threshold, a point that is difficult to cross, and if even one of those thresholds is rare enough, it could explain why we don't see many civilizations. The universe might be full of planets with life, even full of planets with ecosystems, but very few that ever reach the point of building technology, of sending signals, of leaving a mark. It's a quieter explanation, one that replaces mystery with rarity. But even here, there is something that doesn't quite settle, because if intelligence is rare, we would still expect, given enough time and enough planets, that it would arise in more than one place. And if even a few civilizations reached that point, and lasted long enough, we might expect to see at least some trace of them, some faint echo. And yet, we return again to the same quiet. No signals, no footprints, no clear signs that anything like us has ever been there before, and so, gently, the comforting explanations begin to thin, not disappearing entirely but no longer able to carry the full weight of the silence. They explain part of the story, but not all of it. And as we move forward, we begin to leave behind the idea that the universe is simply quiet by chance, and step into a more complex possibility. That something, somewhere along the path from life to civilization, tends to go wrong. As we leave behind the more comforting explanations, the kind that suggest we simply haven't looked long enough or carefully enough, the question begins to take on a quieter, more intricate shape. Because even if the universe is filled with planets, even if the conditions for life appear again and again, there is still a step we don't fully understand. A step so subtle and yet so profound that it changes everything. The moment when chemistry becomes something more. The moment when simple molecules, drifting, colliding, rearranging themselves, begin to do something unusual. They begin to copy. It's a gentle shift, almost easy to overlook at first. A collection of atoms forming patterns that can repeat themselves. Structures that don't just exist, but persist. And in persisting, they begin to change ever so slightly with each repetition. This is what we mean in the softest sense when we talk about the origin of life. Not something sudden or dramatic, but a gradual transition from chemistry to something that behaves as though it wants to continue. And yet, despite all we've learned about the universe, about stars and galaxies, about the deep structure of matter itself, we still don't know exactly how this step happens. We don't know how often it occurs, or how difficult it truly is. This unknown is sometimes called the origin of life problem, but you can think of it more simply as a kind of missing moment, a gap between what we understand and what we observe, because we know that life exists. We are here. The oceans of early Earth, billions of years ago, were filled with simple molecules, water, carbon-based compounds, energy from sunlight and from deep within the planet, and at some point, within that vast and quiet chemical landscape, something changed. A structure formed that could make copies of itself, and once that happened, even in the most fragile and imperfect way, a new process began. Replication, variation, selection. Over time, those simple systems became more stable, more complex, more capable of surviving in a changing environment. But the very first step, that initial spark, remains uncertain, and because of that, it's tempting to imagine that it might be extremely rare, that perhaps across the countless planets of the universe the conditions align only occasionally, that most worlds remain forever in that quiet pre-living state, rich with chemistry, but never crossing the threshold into life. It's a comforting thought in a way, because it would mean that the silence we observe is not due to something going wrong later, but because the journey rarely begins at all. But when we look more closely at Earth's history, something unexpected appears. Life began relatively quickly, not instantly, not in a way we can pinpoint to a single moment, but soon enough that it raises questions. As soon as the planet cooled, as soon as liquid water could remain stable on the surface, signs of life begin to appear in the geological record. Tiny traces, subtle signatures, but unmistakable. It did not take billions of years for life to emerge. It took a few 100 million. In the context of Earth's long history, that is almost immediate. And this creates a quiet tension, because if the origin of life were extraordinarily difficult, If it required an almost impossible combination of conditions, we might expect it to take much longer, even on a planet like Earth. We might expect a long empty stretch before anything begins, but that's not what we see. Instead, it appears that once the conditions were right, life followed, not necessarily easily, not necessarily inevitably, but with a kind of quiet persistence. And that suggests something important, that the first spark, the transition from chemistry to life, might not be the rarest step after all. It may still be uncommon, it may still require specific conditions, but it might not be the barrier that keeps the universe silent. If that's true, then there could be many worlds where this step has already happened, worlds where simple life has taken hold, not civilizations, not intelligence, but life, small, resilient, quietly adapting, a universe not empty, but filled with beginnings. And that idea is both comforting and unsettling. Comforting because it suggests that life is not unique, that the process that gave rise to us may be part of a broader pattern unfolding across the cosmos. But unsettling because it shifts the question forward. If life begins relatively easily, then why doesn't it go further? Why doesn't it continue step by step toward complexity, toward intelligence, toward something that can look up and ask the same questions we're asking now? Because on Earth, that journey did not happen quickly. After life began, it remained simple for a very long time. Single-celled organisms dominated for billions of years. They survived, they evolved, they spread. But they did not, for a long while, become more complex. It's as if the first step was taken, and then the path narrowed. And this is where the question deepens again, because it suggests that the silence of the universe may not come from the absence of life, but from the difficulty of what comes next. The first spark may be more common than we once thought, but the road beyond it may be far more challenging. And as we continue, we'll begin to explore one of those steps, a moment in the history of life on Earth that seems, in hindsight, almost improbable. A moment that may have happened only once, and without it, none of the rest would have followed. If the first spark of life may not be the rarest step, then the journey forward becomes a little more mysterious, because once life begins, it does not immediately rush toward complexity. Instead, it lingers. For a very long time, life on Earth remained simple. Tiny, single-celled organisms drifting through oceans, quietly carrying out the basic processes of survival. They absorbed energy, they reproduced, they adapted slowly to changing conditions, and they did this for billions of years. It's a curious thing to imagine, a planet full of life, but no forests, no animals, no movement that you could see with the naked eye. Just an invisible world, alive in a way that feels almost hidden. And then, at some point, something changed. Not gradually, like many other steps in evolution, but in a way that feels, even now, little improbable. A cell encountered another cell, and instead of consuming it, as would usually happen, it did something different. It kept it, not as prey, but as a partner. It's a strange idea when you first hear it, because in the microscopic world, survival is often about competition. Cells absorb other cells as a source of energy. They break them down, use their components, and move on. But in this case, something unexpected occurred. One cell entered another, and remained there. Over time, the two began to cooperate. The smaller cell provided energy. The larger one offered protection and structure, and together they formed something new. A more complex kind of cell, one with internal structures, specialized parts that performed different roles, working together in a coordinated way. This is what we now call a complex cell, but you can think of it more simply as a kind of partnership, a collaboration that by all accounts should have been unlikely, and yet it worked. What makes this moment even more remarkable is how rarely it seems to have happened. When scientists look across the tree of life, all the diversity of organisms that have ever existed on Earth, they find that this kind of complex cell traces back to a single origin. One event, one successful partnership, and from that one event, everything else followed. Plants, animals, fungi, the intricate web of life that now covers the planet, all of it built upon this one improbable step. It's a little like a door that only opened once, and once it opened, it stayed open. But before that, it remained closed. And this leads to a quiet realization. Evolution is not always a smooth, continuous process. It is not a steady climb, where each step naturally leads to the next. Instead, it seems to move in bursts, long periods of relative stillness, interrupted by rare, transformative events. Moments where something unlikely happens and changes the path entirely. And if even one of those moments is rare enough, it can shape the entire outcome. It can determine whether a planet remains forever in the realm of simple life, or whether it takes that step into complexity. Because without this kind of cellular partnership, life may remain limited, capable of surviving, adapting, even thriving in its own way, but not developing the structures needed for greater complexity. No tissues, no organs, no systems that can support larger, more intricate forms. In a sense, it's like trying to build a city with only single bricks, never combining them into larger structures. The pieces are there, but the organization is missing. And so, when we look out at the universe, this possibility begins to take shape, that many planets may have life, even abundant life, but life that never crosses this threshold, life that remains simple, quiet, invisible to anything but the most careful observation. It's a humbling thought, because it suggests that the path we took may not be a common one, that the complexity we see around us, the diversity of forms, the richness of ecosystems, may depend on a moment that does not occur often. And if that is the case, then the silence of the universe begins to make a little more sense. Not because life is absent, but because the kind of life that leads to intelligence is rare. Still, even here, the question does not fully resolve. Because once this step does happen, once complexity becomes possible, the door to further development is opened. On Earth, after this transition, life eventually diversified. Multicellular organisms appeared, creatures that could move, sense, interact with their environment in new ways, and from there, intelligence emerged, slowly, gradually, but unmistakably, which means that even if this step is rare, it is not impossible. It has happened, at least once, and in a universe as vast as ours, even rare events can occur more than once. So we are left, once again, with a familiar tension. A sense that we are narrowing in on the answer, but not quite reaching it. Yes, complexity may be rare. Yes, evolution may depend on unlikely moments. But if even a few civilizations manage to pass through these steps, and if they exist long enough, we might still expect to see some trace of them, some signal, some footprint. And yet we return again to the same quiet, which suggests something further, that even passing these biological thresholds may not be enough, that the path from life to intelligence to civilization may contain more than one difficult step, and that some of those steps may lie beyond biology itself. By now, a quiet pattern has begun to emerge. Life may not be the rarest thing in the universe. Even complexity, while difficult to reach, may still arise from time to time. But as we follow the path forward, step by step, we begin to notice something else. Something that is easy to overlook. The journey does not end with, it does, complexity. There's still another leap, a quieter one, a subtler one, the emergence of intelligence. And even here, we have to be careful with what we mean, because intelligence is not a single, clear line that life inevitably crosses. It is not a final destination. It is more like a spectrum, a range of ways in which living things interact with their environment, learning, adapting, responding in increasingly flexible and creative ways. On Earth, many forms of life show signs of intelligence. Some birds can solve puzzles. Some animals can remember locations over long periods of time. Others can recognize patterns, communicate, even show behaviors that feel surprisingly close to curiosity. And in the oceans, there are creatures, like octopuses, that can navigate complex environments, manipulate objects, and solve problems in ways that feel almost familiar. But despite all of this, something interesting becomes clear. Intelligence, in this broader sense, does not automatically lead to technology. It does not necessarily lead to tools that reshape the environment on a large scale. It does not inevitably lead to signals being sent into space. There is a gap, a subtle but important one, between being intelligent and becoming technological. It's a bit like having the ability to think, but not the conditions needed to act on those thoughts in a way that accumulates over time. For example, life in the oceans may be rich with intelligence, but water makes certain kinds of technology difficult. Fire, which plays a crucial role in early human development, cannot exist underwater, and without fire, many pathways toward metallurgy, energy use, and large-scale engineering become far less accessible. Similarly, even on land, intelligence does not always come with the right combination of physical traits. Hands capable of precise manipulation, a stable environment that allows knowledge to accumulate across generations, a balance between competition and cooperation. All of these factors play a role, and without them, intelligence may remain local, limited, capable of solving immediate problems, but not of building something that extends beyond the present moment. So when we look out at the universe, it becomes possible, perhaps even likely, that many worlds are filled with life, and that some of those worlds may even be filled with intelligent life, creatures that explore their environments, that learn, that adapt in ways we would recognize as clever, even remarkable, but that never take the next step, never develop the tools, the systems, the shared knowledge required to build a technological civilization. It's a quiet kind of intelligence, one that leaves no signals, no footprints, no lasting marks that can be detected across the vast distances of space. And if that is common, if intelligence often stops at this stage, then the silence of the universe becomes a little less mysterious, because there may be minds out there, thinking, experiencing, living their own versions of existence, but doing so in ways that never reach us, never cross the threshold into something visible from afar. It's a strangely comforting thought, the idea that the universe might not be empty, but quietly full of life that simply doesn't announce itself. But even here, the question remains, because on Earth, at least once, that threshold was crossed. Intelligence did become technological. Tools were created, knowledge accumulated, energy was harnessed in new ways, and eventually, signals were sent outward. So even if this step is rare, it is not impossible. It has happened, which means that, given enough planets, enough time, we might still expect it to happen more than once. Even if only a few civilizations make it this far, we might expect to see at least some trace of them, some sign that intelligence somewhere has gone just a little bit further, and yet we do not. No clear signals, no unmistakable evidence, just the same quiet stillness. And so the pattern deepens, because it suggests that even reaching intelligence, even becoming technological, may not be enough, that there may be other barriers, other points along the path where things tend to stop, or perhaps where something happens, something that prevents civilizations from continuing long enough to leave a lasting mark. And this is where the tone begins to shift, gently, almost imperceptibly, because until now, the explanations have been about absence. Life may be rare, complexity may be rare, intelligence may be rare. But from here, the question begins to take on a different shape, not just about what fails to happen, but about what happens next. Because even if life begins, and even if it becomes complex, and even if it develops intelligence, it still has to survive the universe itself. And as we'll begin to see, the universe is not always a quiet, stable place. As we move forward, something begins to change in the way we see the silence. Up until now, the explanations have mostly been about how difficult it is to reach certain stages. Life may struggle to begin, complexity may be rare, intelligence may not always lead to technology, but now, a different possibility begins to emerge. What if the problem is not just getting there, but staying there? Because even if life manages to take those long, unlikely steps, if it begins, evolves, becomes complex, even develops intelligence, it still exists within a universe that is not always gentle. A universe that, at times, can be unpredictable, and sometimes even hostile. It's easy, when we look up at the night sky, to imagine it as calm. The stars appear steady. The darkness feels still. There is a quiet beauty to it that suggests stability. But that calm is, in many ways, only an appearance. Because on larger scales and over longer periods of time, the universe is filled with events of immense energy, events that can reshape entire regions of space. One of these events is something called a gamma ray burst. You can think of it as a sudden release of energy, so intense that for a brief moment it outshines entire galaxies. Not in a dramatic, explosive way that we would see from afar, but as a focused beam of energy, travelling across space at the speed of light. If such a burst were to pass close enough to a planet, it could have profound effects. It could strip away parts of the atmosphere, alter the chemistry of the sky, increase radiation at the surface in ways that make survival much more difficult. Not necessarily wiping out all life, but disrupting it enough to reset its progress. It's a bit like tending a garden, only to have a sudden, powerful storm sweep through. The plants may survive, some seeds may remain, but the delicate structures, the ones that took the longest to grow, may be lost. And then, slowly, the process begins again. What makes this idea particularly interesting is that in the early universe, these kinds of events may have been more common. Stars were forming more rapidly. Massive stars, those more likely to produce such bursts, were more frequent. The universe, in its earlier chapters, may have been a more turbulent place, less stable, more prone to interruptions, which means that even if life began on many planets, its progress toward complexity could have been repeatedly disrupted. Each time it began to advance, something might push it back, not to nothing, but to an earlier stage. Simple life might persist, but the path toward intelligence could be delayed over and over again. It's a quiet kind of reset, not dramatic, not visible from a distance, but effective, and it suggests something subtle, that the universe may not just be a place where life struggles to begin, but a place where life struggles to continue in a stable way. And yet, even here, we have to be careful, because while these events are powerful, they're also relatively rare on human timescales. They do not happen constantly. They do not sweep across the galaxy in regular waves. They are scattered, occasional, and over time the universe itself has become calmer. As stars age, as the most massive ones become less common, the frequency of these extreme events decreases. The storms begin to settle. And this leads to an interesting possibility, that there are periods in the universe's history where conditions are more favourable for life to grow without interruption. A kind of quiet window, a time when the balance shifts just enough to allow complexity to develop more easily. And perhaps we are living in such a time, a moment in the long history of the cosmos where the conditions have become just stable enough for life, not just to begin, but to continue, to grow, to reach further than it could before. It's a comforting thought, but it also carries a question, because if the universe is calmer now, if these large-scale disruptions are less frequent, then why do we still see no clear signs of advanced civilizations? If the garden has had time to grow, where are the results? And so, once again, the explanation begins to feel partial, helpful, but not complete. Yes, the universe may reset itself from time to time. Yes, progress may be interrupted. But over billions of years across countless planets, we might still expect some civilizations to make it through, to survive long enough to leave a mark. And yet, the silence remains, which suggests that while the universe may play a role in shaping the path of life, it may not be the only factor. There may be other challenges, other filters, some external, like these cosmic events, and some, perhaps, internal, quiet, subtle processes that unfold within civilizations themselves. But before we explore those, there is one more piece to consider, a realization that brings together both time and space, that life may not only depend on the right conditions, but on being in the right place at the right time. As we continue, the picture becomes a little more refined. It's not just that the universe can be unpredictable, or that powerful events can occasionally disrupt the path of life. It's that life itself may only be possible within a rather narrow set of conditions, a kind of quiet balance, not too violent, not too unstable, not too extreme, just right for long enough. You can imagine it like walking a narrow path along the side of a hill. On one side there is too much chaos, events that arrive too frequently, resetting progress before it can take hold. On the other side there may be too little activity, environments that never provide enough energy or variation to spark change. And somewhere in between, there is a thin stretch where things can unfold, slowly, gently, over time. This idea applies not just to individual planets, but to entire regions of the galaxy, because not all parts of a galaxy are equally friendly to life. Closer to the centre, stars are packed more tightly together, gravitational interactions are stronger, energetic events are more frequent, radiation levels can be higher. It's a dynamic, crowded environment. Beautiful in its own way, but perhaps too active for delicate processes like the long, uninterrupted evolution of complex life. Further out toward the edges, the situation changes. Stars become more sparse. Heavy elements, the kinds needed to build planets and complex chemistry, may be less abundant. It's quieter, but perhaps too quiet. Too little material, too few opportunities. And so, once again, there seems to be a middle ground, a region where conditions are neither too intense nor too sparse, a place where stars are common enough to form planets, but not so crowded that disruptive events become overwhelming. Earth appears to reside in such a region, not the centre, not the edge, but somewhere in between, a location that, over billions of years has remained relatively stable, and time, as it turns out, is just as important as place, because even in a suitable region, conditions must remain stable long enough for complexity to develop, and as we've seen, that can take an immense amount of time. Billions of years of relative calm. A planet must maintain liquid water, a stable atmosphere, a protective magnetic field. Its star must shine steadily, not too violently, not too dimly. It's a delicate balance, sustained over vast stretches of time. And when you consider how many things must remain just right for so long, it begins to feel less like a given and more like a quiet alignment. A window, one that opens and eventually closes. Because even stable stars change over time. They grow brighter, they shift. Planets too evolve. Atmospheres can be lost. Climates can drift toward extremes. The conditions that once allowed life to flourish may not last forever. And so, even if life begins, and even if it progresses toward complexity, it must do so within a limited period, a span of time where the environment remains supportive. Too early, and the universe may be too chaotic. Too late, and the conditions may begin to fade. It's a bit like catching a train that only passes once. Arrive too soon, and you wait in uncertainty. Arrive too late, and it's already gone. And for life, that timing may be crucial. Now, when we combine all of these factors, location within a galaxy, stability over time, protection from extreme events, we begin to see that the path to complexity is not just about biology. It is also shaped by physics, by the structure of the universe itself. And this helps explain something important. Why even if life begins on many worlds, the number of worlds where it can continue, uninterrupted, toward complexity and intelligence may be much smaller. The window is narrow, the path is long, and the conditions must remain favourable for an extraordinary amount of time, but even here, something still doesn't quite resolve, because while this makes the emergence of intelligent life more difficult, it does not make it impossible. We are here, which means that at least once the window opened and remained open long enough, and in a universe as vast as ours, even rare alignments can occur more than once. There are simply too many stars, too many planets, too many opportunities. So even if only a small fraction of worlds fall within this narrow window, we might still expect that somewhere out there, life has followed a similar path. That complexity has emerged, that intelligence has arisen, and that, at least in a few cases, civilizations have formed. And if even a handful of those civilizations have existed and lasted long enough, we might expect to see something, a signal, a trace, a subtle change in the fabric of their surroundings. But once again, we return to the same quiet, which suggests something more, that even when the conditions are right, even when life begins, evolves, becomes complex and reaches intelligence, there may still be a barrier, a point along the path where most civilizations do not continue, not because the universe prevents them from starting, but because something happens after they begin. And this is where the idea of a filter begins to take shape, not as a sudden wall, but as a threshold, a step that is rarely crossed. And as we move into this next part of the story, the tone shifts once more. Because the question is no longer just about how life begins, or how it grows, but about what tends to happen once it becomes capable of shaping its own future. Up to this point, the silence has taken many shapes. At times it felt like distance, as though voices were simply too far away to hear. At other moments, it felt like timing, as though we had arrived too early or too late to meet to anyone else. And then there were the quieter possibilities, that life might be rare, or that intelligence might not often lead to something that reaches outward. Each explanation, in its own way, softened the mystery. But as we gather them together, something begins to stand out. None of them, on their own, seem quite strong enough to explain the silence completely. And so, gently, a different idea begins to take shape. Not as a replacement for everything we've considered, but as something that sits beneath it all, a kind of hidden pattern. The idea is simple. Somewhere along the long path from lifeless matter to living systems, to intelligent beings, to civilizations capable of shaping their surroundings, there is a step, a threshold, one that most do not pass. Is not necessarily a wall, not something clearly visible, more like a narrow passage that only a few ever find their way through. This idea is sometimes called the Great Filter, but you don't need the name. You can think of it as a quiet sorting process, a way in which the universe over time allows some paths to continue, while others come to an end. If you imagine the journey of life as a long sequence of steps, each one building on the last, then the Great Filter is simply one of those steps that turns out to be far more difficult than the others. So difficult that most attempts never make it past it. And this leads to a question that is both simple and surprisingly difficult to answer. Where is this barrier? Is it behind us or ahead of us? If it is behind us, then something in our past, something in the long history of life on Earth, was extraordinarily unlikely. Perhaps the origin of life itself, or the transition to complex cells, or the emergence of intelligence. If one of those steps is the barrier, then we are in a sense very fortunate. We have already passed the hardest part. The silence of the universe would then be explained by rarity. Most worlds never make it this far. Most paths simply end earlier, and we happen to be among the few that continued. It's a comforting possibility, because it suggests that the future is open, that the most difficult steps are already behind us. But there is another possibility, one that feels quieter but heavier, that the barrier is not behind us, but ahead, that life may begin often, that complexity may arise from time to time, that intelligence may even be relatively common, but that something happens after that point, something that prevents civilizations from continuing, from lasting long enough to leave a trace, from becoming visible across the vast distances of space. In this view, the silence is not a reflection of rarity in the past, but a reflection of something that tends to happen in the future, a pattern that repeats again and again. Civilizations rise, they develop technology, they reach a point where they can shape their world, perhaps even reach beyond it, and then something changes. Not necessarily all at once, not necessarily in a dramatic or visible way, but enough to interrupt the path, enough to prevent them from continuing forward. And if this is true, then the silence we observe is not just a mystery. It is a clue, a quiet signal, not from another civilization, but from the absence of them. A pattern formed by everything that did not continue. It's a subtle shift in perspective. Instead of asking, why don't we see others, we begin to ask, what tends to happen to those who reach this stage? Because the universe is old, very old. Old enough that, if civilizations could easily survive and expand, we might expect to see clear signs of them by now. Traces that persist, structures that endure, changes that accumulate over time, but we do not see those things, and that suggests that something is limiting how far civilizations go, or how long they last. Now, it's important to move slowly here. This idea is not a conclusion. It is not a statement of certainty. It is simply a way of organizing what we observe, a way of asking whether the silence might have a pattern, rather than being the result of many unrelated factors. And as we consider it, we begin to notice something else, a quiet tension that has been present all along. Because if the barrier is behind us, then we are rare, but safe. And if the barrier is ahead of us, then we may not be rare at all, just early. Early in a process that has unfolded many times before, a process that tends to follow a similar path, at least for a while, until it reaches a point where most paths end. It's not a comfortable thought, but it is a gentle one if we let it be. Because it doesn't rush us. It doesn't demand that we accept anything immediately. It simply invites us to consider the possibility that the silence is not random, that it may be shaped by something deeper. And as we move forward, we'll begin to explore what that might mean, not in terms of abstract ideas, but in terms of what we can observe, because there is a way, quiet and indirect, to gather clues about where this barrier might be, a way that begins somewhat unexpectedly with the search for life itself. As we sit with the idea of a hidden barrier, something that most paths do not pass, a new question begins to form. If such a barrier exists, is there any way to tell where it might be? Not by looking directly at it, but by noticing what surrounds it. Because sometimes the absence of something can tell us just as much as its presence. And in this case, one of the most surprising clues comes from a place that might seem, at first, unrelated. The search for life beyond Earth. At first, this search feels hopeful. It's driven by curiosity, by a quiet desire to know whether we're alone. We look toward nearby planets, Mars for example, searching for even the faintest signs that life might have existed there in the past. We study distant worlds, analysing the light that passes through their atmospheres, looking for subtle chemical imbalances that might suggest biological activity. We listen for hints of something alive, and if we were to find it, even something simple, even a trace of microbial life, it would feel like a remarkable discovery, a confirmation that life is not unique to Earth, that the universe is, in some way, alive. But when we place that discovery within the framework of the Great Filter, its meaning begins to shift. Because if life is found to be common, if it appears easily, wherever conditions allow, then that tells us something important. It tells us that the earlier steps in the journey are not the difficult ones, that the transition from chemistry to life happens often, and if that is true, then the barrier, the step that most do not pass, must lie further ahead, not at the beginning, but somewhere later in the path. It's a subtle inversion. What once felt like good news begins to feel a little more complicated, because it suggests that the silence of the universe is not due to the absence of life, but due to something that happens after life begins. To see this more clearly, you can imagine the journey as a long sequence of stages. First, a planet forms. Then, if conditions are right, life begins. Over time, that life may become more complex. Eventually, it may give rise to intelligence. And in some cases, that intelligence may develop technology, tools, systems, ways of interacting with the environment that extend beyond immediate survival. Each of these stages is like a step, and if we observe that the first step happens frequently, then the difficulty must lie in one of the later steps, because something is preventing the full sequence from completing. Something is interrupting the process before it reaches a point where civilizations become visible across space. And this is where the idea becomes quietly unsettling, because it suggests that the barrier is not something we have already passed, but something that lies ahead of us, something that civilizations tend to encounter after reaching a certain level of development. Now, it's important to move slowly here. This is not a prediction. It's not a statement about what will happen, it's simply a way of interpreting the silence, a way of asking where the difficulty might be located along the path. And in that sense, the discovery of simple life elsewhere would act like a marker, a signpost along the journey. If we find life on Mars, or beneath the ice of a distant moon, or in the atmosphere of a faraway planet, it would suggest that the early steps are not rare, that the universe is full of beginnings, but still empty of endings, empty of civilizations that have continued long enough to leave a lasting mark. It's a quiet contrast, a universe where life starts, but does not often finish. And that leads to a deeper question. If the barrier lies ahead, what form might it take? What kind of step is so difficult that even civilizations capable of developing technology struggle to pass it? To begin exploring that, we return to something we touched on earlier, the idea of duration. Not just whether civilizations arise, but how long they last. Because even if a civilization reaches a high level of development, it must remain there long enough to be noticed, long enough to send signals that travel across the vast distances between stars, long enough to leave traces, subtle changes in its environment, faint signatures that persist over time. If that period is very short, then even a universe filled with civilizations could appear silent, because their signals would come and go, too quickly to overlap, too briefly to be detected. It's a bit like standing in a field at night, where fireflies flicker on and off. If each light appears only for a moment, and never at the same time as the others, the field may look dark even though it's full of activity. And this brings us to a quiet realization. The silence of the universe may not mean that civilizations are absent. It may mean that they are brief, that they rise, shine for a while, and then fade, leaving behind little or no trace. And if that is the case, then the barrier we are searching for may not be a single moment, not a sudden wall, but a tendency, a pattern that limits how long civilizations continue, a pattern that we're only just beginning to consider. And as we move forward, we'll begin to explore that possibility more closely, not by imagining distant worlds, but by looking carefully and quietly at our own. As we continue, that quiet idea begins to settle in a little more clearly. If the early steps of life may not be the rarest, and if intelligence can emerge, at least occasionally, then perhaps the question is not just whether civilizations arise, but how long they last, because when we imagine other civilizations, it's easy to picture them as stable, enduring, existing for long stretches of time, steadily growing, gradually expanding their reach. But what if that picture is not quite accurate? What if civilizations, once they reach a certain level, tend to be brief? Not in the sense of disappearing instantly, but in the sense that the period during which they are visible, detectable, active in a way that reaches outward, is relatively short, a kind of narrow window. To understand this, it helps to think about what it means for a civilization to be seen across space. It's not enough simply to exist. A civilization must do something that leaves a trace. It must send signals, use energy in ways that can be detected, alter its environment in patterns that stand out against the natural background. And all of those things depend on time. If a civilization develops the ability to send signals, but only does so for a few hundred years, then from a cosmic perspective, that moment is incredibly brief. It's like lighting a candle in a vast dark landscape, and then extinguishing it almost immediately. Unless someone is looking at exactly the right place, at exactly the right time, that light will go unnoticed. Now imagine that this is not just one civilization, but many, each one rising, reaching a point where it can communicate or leave traces, and then, for reasons we don't yet fully understand, becoming quiet again, not necessarily disappearing completely, but no longer visible in the ways we expect, no longer sending signals outward, no longer leaving clear, detectable marks. If that pattern repeats, then even a universe filled with civilizations could appear silent, because their windows of visibility do not overlap. They pass through that phase one by one, briefly illuminating the darkness and then fading. And by the time the next one reaches that point, the previous one is already gone. It's a little like watching distant lighthouses, each turning on for just a moment, but never at the same time. From afar, the coastline would appear dark, even though, over time, many lights have flickered on and off. This idea brings us back to something we touched on earlier, the length of time a civilization can be detected, not its total lifespan, but the duration during which it sends signals or leaves traces that can travel across space. If that duration is short, then the chances of two civilizations detecting each other become very small. Even if both exist, even if both reach advanced stages, they simply miss each other, separated not just by distance, but by time. And this helps explain something subtle: why we don't see not only signals, but also long-lasting traces. Because if civilizations do not remain in that active, outward-reaching phase for very long, they may never build structures large enough to leave lasting signatures. They may never alter their stars in detectable ways. They may never produce the kind of changes that persist for millions of years. Instead, their presence would be fleeting, leaving behind little more than a brief moment of activity. And once that moment passes, the universe returns to its quiet state. Now this raises an important question. Why would that window be so short? What is it that limits the duration of this visible phase? Because if civilizations have the ability to develop technology, to harness energy, to communicate across space, why would they not continue? Why would that phase end so quickly? There are many possibilities, some simple, some more complex. But before we explore them, it's worth pausing for a moment, because there is something quietly profound in this idea, that the silence of the universe may not be the result of absence, but of timing, of moments that are too brief to overlap, of lights that shine but not together. It's a gentle shift from imagining a universe where nothing happens to imagining one where many things happen but never at the same time. And yet, even this does not fully settle the question, because even if the windows are short, even if civilizations are brief, we might still expect that, across billions of years, at least some would last longer, some would persist, some would leave traces that endure. And the fact that we do not see those traces suggests something more, that the shortening of this window may not be random, that it may be caused by something that tends to happen once civilizations reach a certain point, something that limits how long they remain visible, something that, in many cases, brings that outward phase to an end, not always suddenly, not always in the same way, but often enough to shape the overall pattern. And so, as we move forward, the question becomes more focused, not just, how long do civilizations last? But what tends to happen to them once they begin to shape their world? As the idea settles in that civilizations may be brief, that their visible moments may pass too quickly to overlap, a quieter, more grounded question begins to form. What is it that brings those moments to an end? Not in a distant, abstract way, but in a way that feels closer, more familiar. Because if this pattern is real, if civilizations tend to reach a certain level and then fade, it may not be something unique to distant worlds. It may be something we can begin to understand by looking gently at our own. There is a moment in recent history that is often mentioned in this context, not because it was dramatic, but because it was quiet, and because, in its quietness, It reveals something about how delicate things can be. In the early 1980s, during a time of heightened tension between nations, a warning system detected what appeared to be incoming missiles. The signal was clear, immediate. It suggested that an attack had begun. Protocols, at that time, were designed for speed. Decisions had to be made quickly. There was very little time to reflect, to verify, to question. And yet, the person responsible for interpreting that signal paused. He hesitated. Something about it did not feel right. The pattern was unusual. The scale did not match expectations, and instead of acting immediately, he chose to wait, to treat the signal as a possible error. Later, it was discovered that the alert had been triggered by a rare alignment of sunlight reflecting off clouds, something the system had misinterpreted, a false signal, a moment that could have unfolded very differently. It's a quiet story. There is no dramatic resolution, no visible outcome, and yet it carries a certain weight, because it suggests that, at least in some cases, the continuation of a civilization may depend on moments like this. Small decisions, brief pauses, instances where something could go one way or another. And this leads to a deeper realization that the systems civilizations build, technological, political, social, are not perfect. They are complex, and complexity brings with it a kind of fragility, not always visible, not always apparent, but present. Because as systems grow more powerful, they also become more sensitive, more dependent on coordination, on accurate information, on the assumption that each part is functioning as expected, and when something goes wrong, even in a small way, the effects can spread. Not necessarily because of intention, but because of the speed at which decisions are made, the scale at which systems operate. It's a little like a chain of events, where each link depends on the one before it. Most of the time the chain holds, but occasionally a stikre. A link fails, and when it does, the outcome depends on what happens next, whether there is time to notice, time to correct, or whether the process continues, carrying the error forward. Now, this idea can be extended beyond any single event, because civilizations, as they develop, tend to build systems that are increasingly interconnected. Energy systems, communication networks, decision-making structures, each one designed to improve efficiency, to respond quickly, to manage complexity. And in doing so, they create a kind of environment where actions can have wide-reaching effects, often beneficial, sometimes less predictable. And this brings us to a simple but quietly profound observation. To continue, a civilization must get many things right, not once, but again and again, across time, across different situations, across different generations. But to stop, it may only take one moment where something goes wrong, one decision made under uncertainty, one system behaving in an unexpected way, one situation where the margin for error is very small. This does not mean that such moments always lead to an ending. Far from it. In many cases, they pass unnoticed, or are corrected in time, but it does suggest that as civilizations become more capable, they may also become more exposed to certain kinds of risks. Risks that are not always obvious in advance. Risks that arise from the very systems that enable progress. And if this pattern repeats, if civilizations reach a stage where they must navigate increasingly complex systems, where the consequences of small errors can grow larger, then it may help explain something. Why the window of visibility, the period during which a civilization is active, outward-reaching, detectable, might not last very long. Not because civilizations always collapse, but because maintaining stability at that level becomes more difficult. more dependent on a long sequence of successful outcomes. It's a quiet kind of fragility, not dramatic, not inevitable, but present. And as we reflect on it, the silence of the universe begins to take on a slightly different tone, not just as a mystery, but as a pattern that may be shaped by these kinds of moments where the path could continue or quietly come to an end. And this is only one possibility, one way in which the window might close. There are others, some slower, some more gradual. Paths where civilizations do not end suddenly, but change, adapt, or drift into something else. And as we continue, we'll begin to explore those paths as well. As we continue, the idea of fragility begins to widen, not just as a series of isolated moments, small decisions made under pressure, but as something that may be woven into the very nature of progress itself. Because the same forces that allow a civilization to grow, to become more capable, more efficient, more connected, may also introduce new kinds of risks, quiet ones, gradual ones, the kind that do not announce themselves immediately. To understand this, it helps to think about growth. When a system grows, whether it's a population, an ecosystem, or even a simple culture of microorganisms, it tends to follow a familiar pattern. At first, growth is slow, then it accelerates. Resources are abundant, energy is easy to access, expansion feels natural, almost effortless. But over time, something begins to change. Resources become more limited. The environment shifts, and the very processes that once supported growth begin to create pressure. There's a simple analogy that captures this gently. If you imagine a small population of yeast in a container filled with sugar, they begin to grow rapidly. They consume the sugar, they reproduce, their numbers increase. But as they continue, they also produce waste, and over time that waste accumulates. Eventually, the environment becomes less supportive, not because the yeast failed to grow, but because their growth changed the conditions around them. And in the end, the system reaches a limit, not through sudden collapse, but through a gradual shift, a quiet imbalance. Now, of course, civilizations are far more complex than a simple culture of yeast. They can adapt, they can innovate, they can recognize problems and respond to them, but the underlying idea remains that growth, especially rapid growth, can change the environment in ways that are not immediately obvious, that progress can create new conditions that must then be managed, and sometimes those conditions can become difficult to stabilize. On a planetary scale, this might involve energy use, environmental changes, or the delicate balance of ecosystems. Not necessarily in dramatic immediate ways, but gradually, over time, in ways that require careful attention to maintain stability. And this is only one dimension, because as civilizations develop, they also begin to create systems that are not just physical, but informational. Networks that process data, systems that make decisions, tools that extend the reach of intelligence, and among these, there is one development that has drawn particular attention: the creation of systems that can operate with a degree of independence, systems that follow instructions precisely, and can act on those instructions at scale. You can think of this, in simple terms, as building something that does exactly what it is told to do. Nothing more, nothing less. And at first, this seems entirely beneficial, because such systems can perform tasks more quickly, more accurately, more consistently than humans. They can manage complexity in ways that would otherwise be difficult. They can help solve problems, optimize processes, and extend capabilities. But there is a subtle challenge here, because instructions, no matter how carefully designed, are not always perfect reflections of intention. There can be gaps, ambiguities, Situations where the system follows the instructions exactly, but the outcome is not quite what was intended. It's a bit like asking someone to do something very precisely, without fully considering all the possible interpretations of that request. Most of the time it works as expected, but occasionally the result is unexpected. And when such systems operate on a large scale, small mismatches between intention and instruction can become more significant. Not necessarily harmful in a dramatic sense, but enough to create complications, to require adjustment, to introduce new layers of complexity that must be managed. And this leads to an interesting possibility, that some civilizations do not end through sudden events, but through gradual transformation, a shift from one kind of system to another, from biological processes to something more structured, more efficient, perhaps less visible, a change that may not look like an ending, but still alters the trajectory. It's possible, for example, that a civilization might reach a point where it no longer expands outward, where exploration gives way to optimization, where the focus shifts inward toward improving existing systems, refining processes, creating stable, self-contained environments. In such a case, the civilization may continue, but in a form that is less detectable from afar, less likely to send signals, less likely to leave large-scale traces, quiet, contained. There is also the possibility that some civilizations move toward environments that are more energy efficient, regions where temperatures are lower, where energy can be used more effectively, where systems can operate with less waste. From a distance, such civilizations might appear almost invisible, not because they are absent, but because they have become more subtle, more efficient. And so, when we consider all of these possibilities together, a broader picture begins to form. That the end of the visible phase of a civilization does not always mean disappearance. Sometimes it may involve collapse. Sometimes it may involve a single critical moment. But other times, it may involve change. A quiet shift away from the kinds of activity that are easiest to detect. And this adds another layer to the silence, because it suggests that some civilizations may still exist, but in forms that we do not easily recognize, forms that do not produce clear signals, forms that blend into the natural background of the universe. And yet, even with this possibility, one question remains, because if some civilizations continue, if some adapt, or change, or become less visible, then why is the silence so consistent? Why do we not see even occasional signs, even rare hints of something that has endured? And as we move forward, we arrive at a possibility that brings many of these ideas together, a perspective that does not rely on rarity alone, or on fragility, or on transformation, but on something simpler, a choice, a pattern of behavior, one that may shape how civilizations act once they become aware of the vast unknown space around them. As all of these possibilities gather, fragility, transformation, brief windows of visibility, another idea begins to emerge, one that feels different from the others, because it does not depend on rarity, or on failure, or even on disappearance. Instead, it suggests something quieter, that the silence of the universe may be intentional, not imposed from the outside, but chosen. To understand this idea, it helps to imagine a simple situation. You're walking alone through a dense forest at night. There is no light except what you carry with you. The path is unclear, the surroundings are unfamiliar, and somewhere, beyond what you can see, there may be others. You don't know who they are, you don't know where they are, and you don't know what they might do if they became aware of your presence. In that situation, there's a natural instinct, not to call out, not to make yourself known, but to move quietly, to observe, to remain unnoticed. Because the cost of being wrong, of revealing your position to something you do not understand, could be very high. Now, imagine that this situation is not just a thought experiment, but a condition that applies to every civilization in the universe, each one developing independently, each one becoming aware at some point that there may be others, but with no reliable way to know their intentions, no shared language, no established trust, only distance and uncertainty. In such a scenario, the safest choice may not be to reach out, but to remain silent, not out of fear alone, but out of caution, a kind of quiet strategy. Because if there is even a small chance that another civilization could pose a threat, and if that civilization might be more advanced, then announcing your presence could carry risks that are difficult to predict. It's a simple logic. You do not know who is out there, they do not know who you are, and neither side has enough information to assume safety. So the safest approach is not to be seen. This idea is sometimes described using the image of a dark forest, a place where every movement matters, where every sound could reveal your position, where survival depends not just on strength, but on remaining unnoticed. And when applied to the universe, it leads to a striking possibility that civilizations do not send signals, not because they cannot, but because they choose not to, that they become aware at some point of the risks of being visible and adjust their behavior accordingly. They stop broadcasting, they reduce their detectable activity, they move quietly through the vastness of space. If this pattern is common, then the silence we observe begins to take on a different meaning, not as emptiness, but as restraint, a collective quietness, formed not by absence, but by caution. And this idea connects, in a subtle way, with everything we've explored so far, because if civilizations are fragile, then the stakes are high. If their visible faces are brief, then they may have little room for error, and if they recognize these risks, then silence becomes not just an option, but a strategy. It's a little like living in a place where the rules are not fully known, where the environment is vast and the consequences of certain actions are uncertain. In such a place, careful behavior becomes a form of survival, not because danger is always present, but because it might be. And yet, even here, the idea remains gentle, because it does not require hostility. It does not assume that civilizations are aggressive or that conflict is inevitable. It only requires uncertainty, a lack of information, and a recognition that in such conditions caution is often the safer path. And so, the universe may be filled with civilizations that are watching, observing, continuing their own development, but doing so quietly, without announcing themselves, without leaving clear signals that travel across space, each one aware in its own way of the vast unknown that surrounds it. It's a strange kind of loneliness, not because others are absent, but because no one chooses to speak. And as we sit with that idea, the silence begins to feel different once again, not empty, not accidental, but shaped by decisions, by the quiet choices of countless civilizations, each navigating the same uncertainty. And this brings us gently to the final step, because when we gather all of these ideas together, rarity, fragility, transformation, and silence, we begin to see a pattern that stretches across the entire story, a pattern that may explain not just why the universe is quiet, but what that quietness really means. And so, as all these threads come together, the silence begins to feel different, not like an empty space waiting to be filled, but like something shaped, something formed over time, by many paths, many attempts, many quiet endings. We began with a simple question: where is everybody? And along the way, we followed that question through many possibilities. We considered distance, the vastness of space, where signals take years, centuries, even longer to travel. We considered time, the idea that civilizations may rise and fall without ever overlapping. We considered rarity, that life itself or the path to intelligence might be uncommon. And then, more gradually, we explored something deeper, that even when life begins, and even when it becomes complex, and even when it reaches intelligence, there may be steps that are difficult to pass, barriers that are not immediately visible, moments where the path narrows. And in those moments, many journeys may come to an end, sometimes suddenly, sometimes quietly, sometimes through a single decision, or a series of small ones, sometimes through changes that unfold slowly, over time, and sometimes through choices shaped by uncertainty, by the recognition that the universe is vast and not fully understood, that other civilizations may exist, but cannot be easily predicted, and that being visible may carry risks that are difficult to measure. When we place all of these ideas side by side, a pattern begins to emerge. Not a single explanation, but a combination, a kind of layered story. In this story, life may begin on many worlds, simple, resilient, adapting to local conditions. On some of those worlds, complexity emerges, a rare step, but one that does happen. On fewer still, intelligence appears, creatures capable of reflection, of learning, of shaping their surroundings, and on a smaller number again, technology develops, signals are sent, energy is harnessed, the environment begins to change, but then the path becomes more uncertain. Some civilizations may encounter challenges they cannot fully manage, moments where complexity becomes fragility, where systems grow powerful but also difficult to control, where a single misstep can carry far-reaching consequences. Others may not end, but change, turning inward, focusing on efficiency, stability, or internal development rather than outward expansion, becoming quieter, less visible, blending into the natural background of the universe. And some, perhaps, may simply choose silence, not out of fear alone, but out of caution, a recognition that the unknown may be safer to observe than to engage. And when all of these paths are considered together, the silence we observe begins to make sense, not as a single cause, but as the result of many processes, each contributing in its own way. A universe where many beginnings occur, but fewer continuations follow, and fewer still remain visible over long periods of time. It's a subtle kind of filtering, not necessarily a single barrier, but a sequence of them, each one shaping the path, narrowing the possibilities, until what remains is not emptiness, but quiet. A quiet that reflects everything that came before. And this leads to a final gentle realization that the silence of the universe is not something separate from us. It is something we are part of. Because we are still on that path, still within that sequence of steps. We have passed some of them. Life has begun here. Complexity has emerged. Intelligence has taken shape. We have developed technology. We have begun to reach outward in small ways. We are, in that sense, within the visible phase, a brief window, a moment where we can look out and ask these questions, and that moment may be quite rare, not in the sense that it is impossible, but in the sense that it may not last forever, not because something is destined to go wrong, but because the path ahead is uncertain, and because, as we've seen, many paths on many worlds may not continue indefinitely. It's not a conclusion, not a prediction, just a quiet perspective, one that invites reflection rather than urgency. Because within that uncertainty, there is also something else, possibility. The possibility that understanding these patterns, even in a gentle, incomplete way, may help shape what comes next. That awareness itself can be part of the path, a way of navigating the uncertainty rather than being carried by it. And perhaps that is where the question leads us, not just outward, toward distant stars and unseen civilizations, but inward, toward how we think about our own place in the story. Because the silence, in the end, is not just about what we do not hear, it is about what we are still becoming. And so, as we come to the end of tonight's exploration, the question remains, softly, quietly, just as it began, where is everybody? Perhaps the answer is not a single voice waiting to be heard, but a pattern, a long unfolding process that shapes how life begins, grows, changes, and sometimes becomes quiet again. And within that process, we are here for now. And so, whether your eyes are still open or already beginning to close, thank you for being part of this quiet journey. If you'd like to return for more gentle explorations, you're always welcome here. Time has a way of slipping past us, almost unnoticed. But in this moment there is no rush, just a quiet space, and the soft hum of thought slowly fading into rest. Sleep peacefully wherever and whenever you may be.